Okay, you can go.
Okay. Wait. So the data I used is from the NYC Open Airbnb data, and the variable I was trying to synthesize is the number of days a property is available for listing on Airbnb, and I chose this variable because I believe this may disclose some like the disclosure of this data may like expose some property to crimes, because there were like previous study that found that there's a correlation between the number of B&B in an area and the property crimes in that area. And the variables I used for the synthesized model include a neighborhood group, which is the neighborhood a property is located in, being Bronx, Brooklyn, Manhattan, Staten Island, and Queens in New York City. And the room type of the listed property being shared room, private property, and private room and entire house or home. And number of reviews a property has on the Airbnb website. And the neighborhood group and room type are categorical data, and number of review is a continuous data. In order to model the availability data, I categorize it into 6 categories using 60 days as an interval. And we used probate regression to model this data. And we constructed a predictor called XI, and the XI consists of neighborhood group, room type, and log review. I basically like log review, just a log transform review, so we can bring it to a more normal scale. And to fit the predictor XI, I originally didn't do this, but I was like, as I was experiencing some like problem with the false match race, I went back to my model and changed all the neighborhood group and room type data to binary variables, being Brooklyn, Manhattan, Queens, Staten Island, and Bronx, and private, entire, and shared. And what that means is like, if Brooklyn I takes a value of 1, that means like that property is in Brooklyn, and all the other binary data, binary variables should have a value of 0 in the neighborhood group, and same for the room type. And this is the probate regression I used. It basically just used a parameter beta to map the XI predictor into a dummy variable ZI, then use a function called G to convert the dummy variable ZI into the categorical variable we wanted. And a GIP sampler with 10,000 iterations was run, and the beta and G value from the last iteration was used for the synthesize. And this is the a plot comparing the original versus the synthesized data. As we can see, like the distribution of the 2 data sets are highly similar, except for category 6. We have less category 6 in the synthesized data set and more category 4 and 5 in the synthesized data. And in terms of utility measure, I calculated the propensity score, and the resulting propensity score is 0.0022, which is pretty low and really like close to 0, suggesting that a logistic regression cannot distinguish between the original and the synthesized data set. And there's a high level of utility in the synthesized data set. And for I measure the identification disclosure risk, and I assume the intruder knows about the exact neighborhood area and room type of a property. When it comes to pricing, I had 2 sets of intruder knowledge. One's that like they have the perfect knowledge, they just know exactly how much a property is listed on the website. And the second assumption is that they don't, since the price is fluctuating regularly on the Airbnb website, they don't have the exact knowledge, but they have a knowledge of like their knowledge is noise added. So I used the actual price plus a normal 0-3 distribution to simulate this noise, and I evaluate the disclosure risk based on those two assumptions. And here's the result. For the reference, the scenario 1 refers to when the intruder has perfect knowledge, and scenario 2 refers to when the intruder has knowledge about the noise added pricing data. And the ask value is the number of unique matches in the synthesized data set. And as we can see, we get more unique matches when the intruder has perfect knowledge, which makes sense because the pricing data, like the pricing data of the synthesized data set are like exactly the same as the original one. So they should have more knowledge about the inference they make. And the expected match risk are both pretty low for the two scenarios, and the highest being scenario 1 being 0.00112. And that's being 55.07. That suggests the probability of each record in the dataset to be correctly identified as 0.00112, which is pretty low. And the true match rate suggests that under scenario 1, only 7 records are true matches out of 45 unique matches. And under scenario 2, 2 records are true matches with 29 unique matches. And for false match rate, scenario 1 has 38 matches that are false matches, and scenario 2 has 27 matches that are false match rates. And as we can see, scenario 2 has significantly lower disclosure risk than scenario 1. This is because we have added the noise to intruder's knowledge, and making a correct identification will be harder since their information is biased. And wrapping it up, the synthesized model we used produced a similar synthesized number of days available variable compared to the original dataset. And the synthesized dataset has a low propensity score, which suggests it has a high utility. And it also has low identification disclosure risk under both scenario 1 and scenario 2. And with scenario 2 has even lower disclosure risk than scenario 1. And I think scenario 2 is more realistic because Airbnb price do fluctuate a lot depending on the season and like total number of days you're booking it for. So I think it's more realistic for the intruder to not know the exact pricing for the entire year, but have some noise in their knowledge. For limitation of this study, I think because when converting the number of days available variable into categories, I use 6 categories, and that means like categories for record whose value is right at the cutoff points near the categories. It may not be that like representative of the data property, because if the cutoff point is like 300 days for category 6, and we have a property that is available for 299 days, that doesn't mean it is really different from a category 6 property. So I think selection of the cutoff points and number of categories we break this variable into may influence the result of the analyses. And also when we are evaluating the identification disclosure risk, we categorize the price variables into different categories to do the matching. And selecting too many categories may further increase the difference between two scenarios, because if we choose too many categories, the difference of the noise added pricing data will be much larger than the original data set, and that way we'll have a lower disclosure risk. But in reality, that's probably not true. and that's only because of how we did how we measured the disclosure risk and what we did in the model. And that's my references.
All right, thank you, Reese.